In this lesson, we're going to have a look at what we call the standard deviation. And it's a measure of spread of data away from the mean. So if you have a look at this, we've looked at the interquartile range already. The standard deviation is better than the interquartile range to measure this idea of spread. And the reason for it is that the interquartile range only requires two numbers. Remember that includes what we call the lower quartile, okay, or we'll actually call that quartile 1, and the upper quartile, quartile 3. And when we subtract quartile 3 and quartile 1, we get what we call the interquartile range. So we don't need that little L there. All right, so that's our interquartile range. So it measures how far apart scores are. However, when we use the standard deviation, the important thing to remember here is that the value includes all the scores. Just like the mean uses all the scores, so the standard deviation does. Now the standard deviation is defined here by finding the distance of all the scores from the mean, and then we average them. Now what that means is that we could find, and say one score is 5 marks away from the mean, another score is 3 marks, and so on. You find out those distances apart and then average them. That's called the standard deviation. So it says here, in the same way as the mean, mode and median were typical scores. Now remember, they measured the central tendency or the middleness of the scores. The standard deviation is also what we call typical, but it is measuring the distance away from the mean, so it's the spread. So the important thing to remember is that if you've got a small standard deviation compared to a large one, then it means that there's a smaller spread of scores. So if you get a standard deviation number that is small, then it means that the numbers must be close to the mean. Whereas if the standard deviation is big, it means that the numbers are more spread out. So it can be calculated using algebra, but using your calculator is far easier, and that's what I want you to do. Now, I've said here that you need to go back and use the same method as calculating the mean, but just add this as far as steps are concerned to get your standard deviation. So I want you to go and do that and see how you go with it. So here's an example of scores where you've got 2, 3, 5, 1 and so on. Now that's the answer for the standard deviation, and you'll notice that the standard deviation has got a button like that, and then there's another one that looks like that. This is the one that I want you to be pressing at the moment. It's called the population standard deviation. This one we're going to deal with in a little while, so don't press it just yet. When you've done that, I'd like you to set up your calculator so you can enter scores and frequencies. Scores and frequencies. So you've got the two tables, remember, in your calculator, with your scores down here and your frequencies here. Alright, get that up, measure it through, and do it for this set of data, and check that you get the mean of 6.95 and a standard deviation of 1.20, and that's to 2 decimal places. Now you can pause the video whenever you like to try this out, but you must start making sure that you can get those numbers. I'm going to move on, so if you like to pause it now you can, and then we'll go on together. Alright, in this particular case, what we've got is some information for group data. What do you do to work out the standard deviation if you're given group data? Well, all you have to do in this particular case is to work out a class center. Now, when we take 324 and 300 and add them together, 300 and 324, and then divide them by 2, we get our average, and that's our class center. So in this case, it's 312. Likewise, if you average the first and the last, you'll keep getting the class centres. So let's write these in, 337. And once you start to see a pattern, you don't actually have to work out the averages. 362, 387, 412, and 437. Now you're going to use this as your class centre. That's going to be your X value. This is going to be your frequency. So what I want you to do is to put these into your calculator as well. So clear your calculator. Make sure you turn your calculator off then on again so it's all cleared up. And what you need to do is to work out two things for me here. First of all, you need to work out the mean, and that should come to 373.3. That's to 1 decimal place. And I also want you to work out the standard deviation. And the standard deviation for this should be 27.7, and that's also to 1 decimal place. So make sure you can get that. And that's basically saying that all these scores, the average distance from the mean is 27.7 marks or whatever it might be. Okay, so that's how far they are on average away from the mean. All right, now there is one other standard deviation that I want you to have a look at. It says here, and I'll just get a highlight again for us here, that in the same way as there are different types of averages, now by that we mean that you could have had measures of central tendency. So you could have the mean, which measures middleness. You could have median, also measures middleness, and mode. All right. There are also two types of standard deviation. Two types. One of them is called the population standard deviation, and that's the one that we've been working at. That's that key there. Now what that means is if you're given the whole population to work the standard deviation out for, that's the key you press. Whole population, no samples. However, if you've got a sample standard deviation, or a sample rather, of a whole population, just a sample, then you must use this button here, because that's called the sample standard deviation. And the reason why you have to do that is if you use standard deviation, this particular key, for a sample, what happens is that it actually underestimates the standard deviation of the whole population. So don't use this key when you're using a sample to work out standard deviation. You use this other one and it gives a much more accurate reflection of what the real standard deviation is. It's actually the same way as far as calculation. It's done exactly the same way. You've just got to make sure that, just move this over, you've just got to make sure that you press the right button at the right time. Alright, so let's have a look at how this works. So here's a random sample. Notice they call it a sample. So because it's a sample, we're going to make sure we use this button, the sample standard deviation button. Alright, so here are the results. Now what I've done is I've gone ahead for you and worked out the class center of this group data. So all you've got to do is to put in the class center and the frequency in your calculator, and if you do that and press the right button, this is what you should get. Alright, so this is for these particular numbers. You should get a mean of 53, and you should get a sample standard deviation. Remember, because this is a sample of boys, and it should be 9.4, and that's rounded to 1 decimal place. And you might as well just check, I'll just put this in bracket, check what the population standard deviation would be, and you'll find that it'll be actually smaller than the sample, which simply means it's an underestimate of the real deviation, sample deviation, which is 9.4. So practice that, make sure you use your calculators, and in a later topic we'll give more details about the meaning of this whole thing on standard deviation. At this stage, all I want you to do is to be able to calculate it.